So what I'm trying to do is just have a general talk around, how we experience, using BIM, using digital engineering on projects, and a few challenges, and it's just really a little saunter through our use of the technology on projects. So I'm wandering over here this morning and yesterday looking at the city, and I think what really intrigues me about all the stuff that we do is the end result is this built environment, which is, if you think about it, layers and layers and years and millions of people and hours that have been spent creating, our environment. And I think it's really such a great thing that we do. And I think if there's one thing, when I was thinking about why am I in this space? Why do I do what I do? And what is it about it? And I just think for me, it's about creating stuff. It's about making things. And I'm thinking that most of the people in the room here get the same thing. It's a kick out of doing something. It's a kick out of putting stuff together. That technical challenge, and the end result is, it's where we live. It's the human race. It's fantastic. And I think what's really exciting is where we are today. Is we're sort of on the cusp of the next generation of how we're going to do this better and better, and more effectively and more beautifully. So I thought, just a quick look back at, what is it all about? It's about communication. It's about getting people to connect with each other, to understand what someone wants, and how do we take what they want, do this act of creation, join all the dots, and make it happen. And, ancient Egypt, word of mouth, not a huge amount of paperwork. Maybe a bit of stonework was handed around, passed around. Certainly a lot of threat. If you didn't achieve what you wanted to achieve, there may have been, death sentence at the end of it if you didn't get it right. I think the key thing is this communication, the background information flows, and how we trying to get that information to flow effectively such that we can deliver those visions that everyone's looking for. There's an example of one of our projects going back maybe a couple of years, trying to manage that circulation of information to people so that basically all we're trying to do is translate a client or someone who's paying for it to what we're trying to deliver, and make sure that's harmonious as possible. And we use all these systems, document control systems, Insight, AConnect, but still, I think in a lot of cases we can see how ineffective those things can be in terms of translating the initial concept idea all the way through to execution. A lot of grief happens in between them. So how do we deliver complicated projects like this to make the future? All the complex geometries, complex stakeholder, multiple stakeholder engagements. So I think this is the beauty of the new digital age, is the ability to manage this information so much more effectively. And if we can put together workflows and processes to help that, it's just going to make it a lot more seamless, much more effective, and we can deliver on that dream. A key angle to our establishment of workflows is this simple concept, really, based off Adam Martin Fisher's ideas in Stanford. The idea of integrated information, an integrated team, integrated processes, integrated building systems, and therefore, hopefully, high-performance infrastructure. So underpinning that, obviously, then you've got the multiple of all the different softwares and trying to deal with those to make them sing in that environment. Again, a more technical angle, trying to make software interface to be able to deliver that. But if you can design and put together a process and a workflow, which I think all of us do probably on a daily basis, how we have been doing it probably for 20 years, doing spreadsheet transfers, data exports, imports, all those sorts of things. I won't dwell on this too long, but essentially, obviously, the idea is about managing this information effectively. And I think one of the key benefits of BIM is obviously the ability to visualize that information, link it, and the complex projects become a lot more effective because of this ability to link and interlink information, and having the graphical geometry to be the framework around which you can hang all of that. In which case you get far better stakeholder engagement, as I think we've all probably experienced on projects. So I thought I'd flick through a few projects we've done in recent years to show you some of the examples of how we've done this, not in too much detail really, and maybe we can field a few questions at the end if you wanted to ask something more technical around what we've been doing. So it started with one that we finished recently, the Sydney Opera House VAPS project. So essentially, no one can see this. It's underground, but really quite a key project for us in respect of BIM and using the geometry significantly, because it was really a complicated set of parameters that we had to work with. You know, the existing opera house, lots of subterranean voids and tunnels and high water table right near the harbour. So essentially, a lot of model combination, a lot of geometry checking, 3D PDFs even used to help communicate amongst team members, and very effectively helping everyone understand what they had to do. You know, if you can imagine then someone being able to use that information to actually tunnel and dig rock away underneath the opera house. It's quite exciting to think about. Here's a simple example of them checking out nails with existing adjacent. You know, for 2D example, very difficult to conceive and understand it, but as soon as you put it into a model form, very easy to understand. So it's just simple stuff. This is another one of our flagship projects we did recently, Wigan's Island Coal Export Terminal. And all the things that we did on that project were quite interconnected and quite powerful in terms of what we could do with the data particularly. So it was essentially a construct-only project. So really what we were doing is working with models provided and enhancing those models and joining the dots, basically filling in the gaps that you often get on a project. You know, you might get designers providing X, subcontractors providing Y, and then there's gaps and pieces all through that process and workflow that we're talking about. So it was really then our guys trying to work out how we could fill those gaps so we have this more seamless interlinkage and be able to assemble models and assemble and join data together. Example was a lot of that fell back on, we extended the steel detailing scope to include a far higher level of steel detailing. So design model provided by the client on the left-hand side, and on the right-hand side, obviously, a highly detailed steel detailer's model. We included in the scope and other people's scope additional modelling of suspended concrete, cable trays and pipework, which is traditionally aren't modelled at all in these kind of projects, but that meant even short lengths of steel and light metal framing were prefabricated. So another side benefit from that. And also the coordination was obviously far more effective. A little bit of an exercise rather than a real example was just modelling of conjugate and backfill to see how effective that was in terms of progress measurement, etc., quantities. Side benefit of all that modelling was obviously the stillage, nesting and seeing, so this was all fabricated offshore and shipped in, but the ability to then take those elements out of the model and assemble them and effectively, efficiently ship them. Here's an example. So a software called Trackum was used, which tracked so all the model elements are broken down and put into work packages and interlinked, and using Trackum software, the barcoding system, we could track and status. So for example, the top right, you can actually see there's a little marker and really just showing that shipment is actually at the docks. Then interlinking that data, you'll be able to, like I was saying before, work packages, click on the work packages, just Navisworks obviously, be able to show and highlight. But the effectiveness for the project team to understand it so clearly and effectively, and then also, like we're talking about data sets being overlaid, so, it's just a different view. I wanted to see work packaging, I'll look at work packaging. I want to see who the fabricator is, I can see who scope is, I know who to chase up. Very easy, very effective. So again, you can sort by elements as well. So all that data hidden there, it's not confusing, not complex. You don't have to flick through 200 drawings or schedules, all of that. It's actually all one source, single point of truth idea. So all of that obviously helps us to manage project from a scope and progress perspective. And using the Trackum was basically ability to use a GPS scanner and scan when something was in a laydown area. And the side benefit from that was, for example, huge laydown areas on these kind of scale of projects. And often we end up the project's completed and there's probably several tons of steel lying around, mainly because someone couldn't find it the first time they went to the laydown area and they reordered it. So the advantage of this is trying to find that particular work package in the laydown area using GPS coordinates is quite useful. Progress information, again, so it's just again overlaying then scanning that something is in the laydown area, it's installed or it's constructed or it's certified, all of those sorts of things. And then again, just the visualization, very quick, pictures worth 1,000 words. We understand what's happening, where it is. A couple of construction photos, some significant heavy lifting going on for that project. And then the side benefit of all that data is production. And in fact, the project team were a little bit in denial at the beginning when it was first set up and were surprised to see that they were behind program and basically pointed fingers at the software and said, no, your data's wrong. But very quickly it was proved, in fact, that they were slightly behind program. And at least they knew early and were able to catch up. Here's an example, as-built program, so be able to use that information and overlay it against the target programs and as-built program, give you some real data. You can use those metrics then for your next generation of project. Another project we're working on at the moment under construction. We're very proud of it actually, Parramatta Square. This is for Trotter Hall. So we're using BIM for all those activities outlined up there. The way we set this project up, we found on several projects that quite advantageous to set up a co-location, and not just a co-location maybe of designers, but designers, our team members and subcontractors. So we've got this focus. We set up a room, a special BIM room. You see the guys in it there, big screens, workstations, and have collaborative working sessions. How we really want to work to solve issues and resolve problems very quickly, very effectively, using models, using software, and clear direct communication. And one of the guys said to me, he didn't realise how effective it was in terms of solving stuff until we got to a certain stage in design completion and the team started disbanding and left the project office. And then the design manager said to me, he realised that it used to take less than 3 days, maybe sometimes only hours to solve coordination issues. But once they're disbanded, suddenly it's this communication issue and it's like a week at least before anything's resolved. So these are the team led by BIM Consulting, Architectus, Arcadis, WSP Woods Bagot, and the subcontractors, FIP, all staff, and DA Design Fire, and Planet Plumbing. And all of that modelling there is subcontractor modelling, architect modelling, structural modelling. It's real stuff. It's what it's going to be. It's what we need. Another example. So, I certainly believe, and the project team corroborate this, that having the model and having this, it avoids a lot of aggro, because often I think aggro is a result of poor communication, poor understanding. And if you can put someone in front of a model and clearly show them where the issue is, there's far less of a reason to have an argument about something. This is in the basement, all subcontractor modelling and structural modelling. Clash detection. I think the other thing we often, we all obviously know clash detection, we all do it and it's all, but I think we undervalue it, to be honest. Just if you think about any one of these clashes that we solve using the software, in terms of the dollar value to the project, I think so. All of my message is really don't underestimate the value of it. And I think we need to reinforce that value to all of our clients and stakeholders, whether they be internal or external, and just really promote this, because the beauty is, to me, it's a very direct and very positive thing that we can put across to say this is really saving money, it's saving time and all of those things. And if you want it, you've got to do the BIM process. You've got to set up the workflows. You've got to set it all up. If you want this, so it's a great keystone to hook everything around. So I really say don't underestimate it. keep working it and keep seeing the value in it. Another good project where we had a good few learnings was Abercrombie Business School, the University of Sydney. All the things we used BIM for on that project, again, set up a project team co-location for designers, subcontractors, and ourselves in the architect's offices, in fact, servers and workstations and everyone working in a close co-located office. And we found that very effective in terms of design coordination. And the outcomes, I think, were really pretty powerful. So we even modelled the landscape and civil works, which did show it was certainly a challenge to do that with software. I suppose I'm sure a lot of you have experienced that. So it was a challenge, and there were a few workarounds done, but the benefits were clearly a couple of issues that we picked up early because of that. Bit of clash checking again. And ability to use that digital information, in the field. Someone be able to quickly corroborate something, check what was there, and commissioning activities. This is just a small example of a little trial we did in terms of understanding the value of a digital set-out. In specific, this for cases, this example is for ceilings and partitions, as opposed to, I think, becoming more mainstream now that we see MEP set out using Trimble and those kind of devices. This was really to see how effective it could be for something like ceilings and partitions, which is obviously a little more complicated than your elements like fan coil units and products that are basically bolted in. So it was a really good lesson and quite interesting to understand that this is one part of where BIM, the workflow will be slightly different to other parts of the workflow. So the architect's drawings for partitions obviously are really design intent. They don't represent exactly how they might end up. And obviously there's not really, in most cases, cohesive modelling of partitions, and there's probably no need to. So the lesson, there were a good couple of lessons learnt out of it. Again, the idea of then be able to, the digital workflow going through to doing a scan and using that scan to compare it to the design model to see, again, a bit of a trial to see the value out of it. Still probably not really in our space at the moment. We haven't done a lot of this because we're still, the technology and the expertise on the ground is probably not quite there yet. Another project we've just finished in Victoria, a level crossing removal project. This was a pretty intense project, 37-day shutdown on the Frankston line, 4 stations and grade separations that needed to be removed in that 37-day window. Huge planning activity leading up to that, and we did a bunch of modelling, as you can see there, sequence understanding, and the virtual reality headset was probably more of an experiment to understand the benefits of being able to then use that model in the VR situation to see how people could, walk through and look through. And we certainly will be exploring that in more detail in future. One of our flagship projects is the Perth Children's Hospital. Some of you might have seen this already. So all the full-blown BIM project for the clients. All the BIM to LOD 500, been a huge challenge as a project, but we've used it for logistics. I think another ad hoc comment that came out of the project when I was talking to a project engineer who was tasked with planning the builders' lifts or LMAC locations on the project, and it's the first time he'd done it on a job with a model, and he said it was so powerful because he had such good context information to be able to do that exercise. So normally, if you think about trying to plan a location of a builder's lift, you'd have to look through, I don't know, probably 10, 20 drawings, maybe even more. Quite difficult to do, but with the model and the right models, federated, he found it very easy to do and great confidence in where he had ended up locating them. Again, broken into work areas, the ability then to divide the model into work packages. Clash detection, obviously, yet again, very powerful, though, particularly in a hospital or healthcare environment. Services are obviously, as you all well know, Another simple example of using the model is just to, highlight fire-rated partitions and fire-rated doors and make sure there's coordinations occurred. Quite a simple task, but really quite effective. ETAB's structural analysis model. We also used extracted model. I mean, didn't not in anger so much, but more of a trial to see concrete volumes, hydraulic systems. So PDC were our BIM consultant partners on this project and very effective. There's the concrete variances. Another simple example of effectiveness of BIM, though, was signage and wayfinding in hospitals is pretty critical, and the client had a really strong view on this and was really concerned that we got it right. And modelling the signage and wayfinding was really effective. It was just being able to visually show the client rather than try and talk them through a bunch of 2D drawings, just really changed the game. It was, I was in design coordination sessions and I saw the value that we could get sign-off stakeholder engagement immediately when they saw this. And then the other value was obviously the digital data linked to those signs made sure that when they were ultimately fabricated, the information was solid. You could pull a schedule out of it and use the schedule and you had confidence in the information. Ultimately, the project, the client has a requirement to want to operate and maintain it using BIM systems. They're yet to finalise exactly how they're going to do that. So at the moment, there's an exercise in data management, exporting what system they're going to use. And I think this is probably a common example of a lot of projects where you've got the issue of existing systems and wider systems. Obviously, this hospital is only one part of the WA Health organisation. How do you fit that in? Those are, I think, all the challenges that we're probably all going to start dealing with in a couple of years ahead. But the benefit, obviously, to O&M, I think we're all aware of it. And I just thought I'd conclude with this, where my BIM journey started, which was really, there's a short article in the top left there, which a company I dealt with called Skok Systems, and they came up with this system called Drawbase, which was this is back in the 80s. Late 80s, and that was certainly my first understanding of the power of being able to link geometry to data. And I mean, you can see, I don't know if you can read there, but it was really like quite basic idea though, using DXF files, exporting, and maybe 3D linking it through a database. So that's where my BIM journey started, and then, and now I see the next generation basically, being able to come up with a skateboard, my son deciding to make himself a skateboard and had this idea. He saw a really cool one on the internet that he was he wanted to make one though, so I thought, great. Some genes there, obviously. And anyway, so I said, well, why don't you do an inventor? So he did. So he knocked it up in Inventor, and then, okay, we didn't 3D print it, but got some plywood and knocked it up, and anyway, that's the end result. So that's the next generation, and I think, that's the journey. And it's a long road. It's been, from all the way from the 80s to now. And I just think now we're on the horse and we're running and we're galloping. So it's exciting times. Thank you.
So thanks, Don. Some fantastic real-life examples on how BIM can actually improve processes. So we'll just, if there's any questions. Yep.
We're right to ask now.
Yeah, sure.
With your project, level, with your project that you did in Victoria, the level crossing projects, when you model it to that detail, do you have a hard time getting trades and subcontractors that use on those projects to embrace that modelling and use it? Or do you only use it for your own benefit to control those trades, or do they ask for the information so they can use it to, provide a better service and product for you?
Yeah, I was a little bit of a mixed response that we obviously selfishly want to use it for our own instance to manage the project. A lot of that's so a lot of the design work there is, because it's a civil project, it's really, a lot of piles and dirt and trash. So it's quite simple stuff. The stations themselves are quite highly modelled by Grimshaw's at Arabs and that. And then we had a team of people that assisted to put together the construction activities, doing the linkage of the program and showing plant and equipment. It was really quite a military operation to do that. So BIM in some ways was tracking very closely and really just supporting activities that were being done. So the planning was the core focus of it. It was huge in terms of trying to remove, basically, essentially we were lowering those railway tracks so the roadways could go across the top. And by piling, basically, to form a trench so that the roadway could go and the railway line could be lowered. So essentially, putting all those piles in first, and then planning everything and doing, utility removal and all of that, and then waiting for the shutdown, and then having the shutdown, and basically getting and pulling all the existing track and overheads out, lowering the dirt, and then putting the tracks and stuff back and constructing the stations and the bridge decks and all that. So it's very, very intense. In terms of subcontract, there wasn't a huge amount of subcontractor engagement in that, because of the nature of the work. So in the stations, yes, but most of it was really, it's quite simple. Like, we didn't really model the railway lines. That was all string based. So it was modelled, but it was string based. So it wasn't like virtual sort of stuff. I don't know. Does that kind of answer your question?
I'll catch up after.
Anyway, so is there any other questions for Don before we move this through? All good. All right. Thanks, Don. Please, round of applause.